Remote control station controls ships.
Ever-changing world where unmanned and remote-controlled vessels are becoming reality. Let us share a view of this world with you. The control room is the nerve center of remote operations in the Rolls-Royce OX concept, where the global wall shows a real-time overview of worldwide shipping traffic. A full situation overview is presented to operators who are monitoring vessels via world where unmanned and remote-controlled vessels are becoming reality. Let us share a view of this world with you. The control room is the nerve center of remote operations in the Rolls-Royce OX concept, where the global wall shows a real-time overview of worldwide shipping traffic. A full situation overview is presented to operators who are monitoring vessels via remote link from their onshore workstations.
Dynamic positioning reports DGPS-1. Lost connection for vessel RR9835. Suggested course of action. Diagnostics. Commands?
Proceed.
GPS, geopositioning and celestial navigation status. Nominal. INS status. Transmission stopped. Suggested failure mode, physical. Commands?
Stand by. I'll have a closer look.
Drones 01 through 08 ready for inspection flight. Commands?
Launch drones 1 and 2. Flight plan. Standard inspection routine. Camera control. Manual with eye track. Deploy replacement for selected antenna. Schedule post-mortem inspection and change of antenna at next port of stop. Add checkpoint for operator at selected time. Verify navigation data integrity.
The vessel is ready for handover to local operator at West Coast VTS. Transferring administrative documents. Suggested course of action, break and refreshment.
Okay. Leave the documents open when they're ready.
Confirmed.
The OX local wall presents a place where vessels and traffic in the local zone are tracked and controlled, and their port operations are scheduled, controlled, and managed.
Vessel RR9835, pending transfer to local VTS. Administrative documents ready for review and approval.
Okay, review on tablet. List the summary of tagged events for the new vessel on wall.
Vessel RR9876 reports repeated eco-efficiency fluctuation above preset threshold.
Switch experts to local workstation 6.
In OX, situation handling is made efficient with sharing of information and flexible use of data. System specialists are available on demand for problem analysis and assistance.
Welcome.
Show me a summary of propulsion motor operation for the past 3 hours. Play audio.
Vessel tagged with situation handling for all operators.
Right. Bring vessel viz to collaboration table 1.
The OX collaboration table is a tool dedicated to teamwork and in-depth situation analyses and reviews, allowing ad hoc problem solving on a shared and flexible presentation platform.
We are looking at a vessel with possible propulsion motor failure. We need to decide whether she can sail to port with both motors, or if she needs to shut down the other shaft line. Judging by the motor sound, I'm suspecting a failed feedback sensor. We can bypass it by changing to model-based open-loop feedback. And I'm positive she can then sail to port with both shaft lines operational. But I want her to hear your opinions.
With unprecedented flexibility of use, operational efficiency, and resilience against the unexpected, Rolls-Royce OX concept brings you the next generation in marine operations. Rolls-Royce, trusted to deliver excellence.
Few more video clips, but then since I'm running out of time, I'll go back to a few points on my PowerPoint. I'm skipping all of them because we're running out of time. Some survey was done, and this is the result of the survey. The first question is, do you really require people on board? The answer is 84% have said yes, require people on board. Only 8% have said no, we don't require anybody on board. And 6% say, well, nothing happened, they are neutral. And the one on the right, which you see, the picture on the left is whether you require people on board or not. 84% of the people surveyed said yes, we require manned ship. 10% said no, it should be totally unmanned, there need not be anybody on board. And 6% said, well, ambivalent, they were not here or there. The picture on the right says that whether this concept of autonomous ship is technology power provider driven, and a whopping 48% say yes, it is the technology drivers who are talking about it, but not the other users. So from there you can infer whether we are still ready or not. Now what are the timelines? You see, by 2018, they expect remote support operation of certain functions, which is already there. My next slide will show that. By 2020, remote and autonomous local vessels. Local vessels means coastal vessels will be fully autonomous. By 2025, remote and autonomous short sea vessels. And by 2022 it will be remote and autonomous ocean-going vessels. What is the conclusion? Advancement of technology cannot be stopped. So autonomous ships with no crew on board are a distinct possibility in the near future. How near is the future? One has to see. But to reach that destination, a few more important milestones need to be crossed in order to make autonomous shipping absolutely safe, secure, reliable, and legal. No legal framework is in place yet. There is also a need to ensure that there is no adverse socio-economic impact due to introduction of autonomous shipping. Now this is a breaking news. On 3rd of December, the global shipping took a giant leap forward when Rolls-Royce Marine and Finn Ferries successfully completed a trial voyage of world's first truly autonomous ship by deploying car ferry Falco in the congested waters of archipelago south of Turku in Finland. Falco is a double-ended 54-meter car ferry. Falco navigated all by itself around obstacles without human intervention on its outward voyage, and on its return voyage, it was fully controlled from a remote control station 30 kilometers away. On the left you see the control center from where it was controlled on its return voyage. On the right you see the cargo ferry. Now before we leave, I feel that one has to ponder over certain things. The first one is a philosophical statement. If man himself is imperfect, then can man-made devices be perfect? That means, can machine fail or not? The second one is an adaptation from electricity. Electricity is a good servant but a bad master. So is automation. The third one is destructive technology is fine, but destructive technology is not okay. What I mean by destructive, suppose these remote control vessels, fully automatic vessels fall in the hands of the wrong people, what happens? Will it not be a disaster? So one has to ponder over all this, and before signing off, Tolani Maritime Institute, being a premier institute, should start getting ready to be the first to take advantage of the first mover by introducing certain topics as a short course or a full-time program. And these topics should include should have emphasis on digital electronics, automatic control systems, analytics and data sciences, fusion technology, remote diagnostics and fault finding technologies. So therefore, for the officers of the future, probably there will be a convergence. There won't be a deck department or an engine department. It will be common. And these people will have to be trained not only in classes, they should have hands-on training because they have to diagnose from a distant place. Unless you have an hands-on experience, you will not be able to do it. They should have a simulator training and a simulated remote diagnostics and fault finding system. Thank you.
Your suggestions will be well received. Now I request Captain Krishnamurthy Iyer, sir, to felicitate Dr. L.R. Chary with a memento as a token of our appreciation. Thank you, sir. The second keynote speaker of the day is Professor Pei Lin Zhao. Professor Pei Lin Zhao is the Professor of Marine Engineering in the Department of Naval Architecture, Ocean and Marine Engineering at the University of Strathclyde, UK. He received BE Engineering and MSc degree from Dalian Maritime University in China and PhD in Newcastle University, UK. His research area includes high efficient and low emission of marine engineering systems, ship ballast water management or treatment, fuel cell marine applications, alternative fuels, and life cycle assessment for shipping and shipyard processes. He has secured over 6 million pounds of research funding from European Union Framework, Horizon 2020, UK government and industry. He has published over 160 research papers, including 80 international refereed journal papers. Sir, we are very fortunate to have you with us here today. Now I call upon Professor Pei Lin Zhao to enlighten us with his topic, latest developments in marine engineering and naval architecture.
Good morning, ladies and gentlemen. Thank you very much for the introduction, and then thank you, TMI's invitation for me to give this